Please let's join up so that we can start. My name is Dave. Law. Please let's join up so that we can start. Okay. Please let's join up. In 1 minute we'll be starting. If you've not joined, join up immediately. Once it's 11:10, we'll start. No, are you on earpiece? Can you hear me? Hello and welcome. Today we are going to be continuing our series on data structures and algorithms. You say that you use data structures to organize your data. Data structures are like your building block. If you want to build a software, just the same way if you want to build a house, you need your block, you need your zinc. Those are the things you need to build a house, your cement. In that same way, if you want to build a software, you need your data structure, whether it's list, array, queue, stack. Now, once you've gotten these data structures, the next thing will be to do the building. Just like when you get your block, your cement, now you start your out of building. Once you're done, you have your house. In that same way, once you've gotten your data structure, which is your building block for building your software, then you start the out of building the software, which is called algorithm. So the end product is your software. So you see the relationship between data structures and algorithm. You use your algorithm to build up your data structures into software by manipulating them. And that is what we're going to be looking at. We started it yesterday. And you see now, if you want to build a duplex or if you want to build a house that has all these foreign zinc, will you go and buy local zinc to build for foreign zinc? No, you need to use the right materials. In that same way, if you're building a software, where you're supposed to use a list or a dictionary, are you supposed to use a string there? No. So you have to know to pick out the right data structure so that you build out the right software. You see the relationship between building and data structures and algorithm. So the same way you can build a house using your block, your zinc. In that same way, you can build a software using your right data structures like the stack, queue. The art of building the house, which you call construction, by following steps. When you're building the house, you have to do the foundation first, isn't it? You start putting the blocks, you do the lintel, and so on. In that same way, you use algorithm, step-by-step way of building your software. So that is that, and that is how we're going to be introducing. And for me to get heated up immediately, I'm going to quickly share my screen so that we can see these other types. So we looked at inbuilt data structures yesterday, isn't it? Yeah, we looked at the list, the dictionary, the tuple, and the set, isn't it? So today we're going to be looking at the user-defined data structures. That's what we're looking at today, the user-defined data structures. Okay. So what did I say are the user-defined data structures? Who can give me an example of the user-defined data structures? IK, give me an example of a user-defined data structure. Who can give me an example here? Graph, yeah, graph is one example. Which other examples? We have the stack, isn't it? We have the queue, we have the trees, we have the linked list, we have the what? Hash maps, thank you. So those are the data structures. So I'm going to explain these data structures now so that you understand them. So once I'm done explaining these data structures, we should be able to implement them in Python. Is that clear? Everyone, please come and take care of this person. Okay, so let's start. You all know everything that I'm teaching you is already on our website. For our digital audience, just get to Tclassified.com. Click on blog. This is blog. Then you see data structures and algorithms. Click on it. You're going to see our yesterday's class. Here we define what algorithms and data structures are. And you're going to see our built-in data structures like the list, dictionary, tuple, and set, how we explain them and we give examples. Also watch our videos on our channel, Austin Kenneth. Everything is there. So today we are going to be looking at the user-defined data structures. You can see them here. That is also what I have here. If you're going to be watching this video, the recorded version of this video, as I'm explaining this stack, you're going to see the diagram of a stack. So on the edited version, you're going to see. So as I'm explaining the stack now, you will see. So what is a stack? Stacks are linear data structure based on the principle of last in, first out. So what do you call a stack now? I'm going to explain what a stack is with this. This is a collection of my complementary card. This is what we call a stack. You keep one data, you understand? You keep the other one on top, keep the other one on top, keep the other one on top. Are you seeing this? So that's how I stacked up this. That's why you say stack up. You know what stack means, isn't it? Stack of cash. You start making too much money like OBO and Whiskey now, you'll be talking about stacks. You understand? Stacks. That's how you stack up cash, isn't it? So this is an example of stack data structure. Why do we call it first in, last in, first out? Who can tell me the stack that went in first? This is the first one, but this is the second one. You understand? So this is actually the one that went in first. So this is the one that went in last, isn't it? But if you want to take out, which one will you take out? This one first, is it not? So that's why you call it last in, but first out. It's the last that is going in, but it's the first that will be taken out. Can you understand this? Very, very important. If you understand these simple things, you get your data structures and algorithm very well. And I told you, if you want to work for Google or YouTube, Facebook, that's what you're going to be tested on. It's not the other ones we'll be doing that look simple. So that is stack. Do you understand stack now? Do everybody understand what stack is? It's very clear. So the data to be entered last will be the first to be accessed. That's what we just said. This is the last one to be put. Do you understand? But if you're looking, that's the first one out. Are we clear on that? Like pushing and popping. Everybody listen. When we say push, push simply means putting inside it. Is that clear? You're pushing. You understand? This is pushing. When we say popping, you're taking out from the last one. Likely operations that you'll be operating on stacks. They are not the only ones. We'll be looking at other ones. Then Q. Q are linear data structure based on first in, first out. Now, this is what we call Q. When you go to the bank, how do you position yourself in the bank? The first person that comes stays first, is it not? This is the first person, isn't it? This is Ahmad. Ahmad came first. This is Remy. Is that clear? And this is Kashmir. Are you seeing that? So this is what we call Q. You understand? You have two directions. On stack, the down one you cannot access, you only from front. But here, you can see the both of them. You understand? Who will be attended first in a queue? The first person, is it not? So that's why we call it what? First in what? First out. Do we understand this now? First in, first out. Ahmad, is it clear? Can you see the difference between a queue and a stack? Good. The data entered first will be the first to what? Be accessed. Is that clear? It is built also on array structure and can have operation being performed from both this side and this side. Is that clear? The other one stack is only from the up. Can you see that? So that is what we call stack. Like I said, if you're watching the recorded version of this, you will see the picture of stack. You understand? Other pictures apart from the one I just explained come out. Then trees are non-linear. Can you see the difference between stack, queue, and trees? Stack and queue, they are what? Linear. Stack and queue are what? Linear. They are in a straight line. Whereas trees will have branches. You understand? So in the video format, please try and watch it. You'll see the diagram of tree. So trees have what we call roots. And they now have, this root will now be taken to the various nodes. You understand? Just like you have a tree and you have branches. So you're going to see a picture of that. So the root is the node where the data originates from. You understand? So the root is also a node, but it's actually the origin. Trees create hierarchy that can be used in applications like HTML pages. That's what you build HTML pages on. Then we'll talk about linked lists. Linked lists are linear data structure. They are these ones, they are linear, which are linked with one another using a pointer. Can you see the difference? All of them have their difference. And that's why, depending on what you want to build, if you want to build out HTML pages, you apply trees. You understand? If you want to build an image application or music player, you use linked list. You understand? If you want to build out a simple stack related, you use stack. If you want to build the one that relates to queue, so you need to know these data structures. so that you know when to use them. You understand? You should know when to use an array, when to use a list. If the list will be changed, you use a list. But if the elements of the list will not be changed, what kind of data structure will you use? Data type? Tuple. Isn't it? We say that tuples are immutable, isn't it? Then if you want to use something that has a key value pair, what kind of data type do you use? Huh? No? Key value pair. No? Key value pair, we did it yesterday. Dictionary, that's what you use. So know the type of data you use to do a work. Okay? So we say that linked list, the node of the linked list are composed of data and pointers called the nest. So you must have a data and a pointer. For one data, you have to have the data itself and the pointer. That's the second box. You understand? So you're going to see these. Just look by my side here. You see the diagram. These structures are most widely used in image view applications. So you can use trees for image view application and music player application. Then we look at graphs. Graphs are used to store data collection of points and edges. Many applications, such as Google Map. Can you see what Google used in building their Google Map? They built it using graphs. Uber, you know about Uber? The online hailing application. They also use graphs for that. Then hash maps are the same to what dictionaries are in Python. You understand? Hash maps are very close to dictionary. They can be used to implement applications such as phone books. You understand? You know, in your phone book, if your name is Ahmad, then you will now have your phone number, isn't it? Key value pair, isn't it? So you use hash maps for such. So these are the user-defined, what's it called? Data structures. These data structures are the same thing for both if you're using Python, if you're using C++, if you're using Java, the same things, you understand? But the ways they are implemented and the syntax, that's where you have the difference. So those are the built-in user-defined data types. And we looked at algorithm yesterday. We said that algorithms are rules or instructions that are formulated in finite and sequential order to enable us solve problems. And they are provided in pseudocode to problem. Now, I want you guys to write out the algorithm of getting yourself to Tclassified every morning. So it's a quick assignment. I'll check it now. So open up your command prompt, just like I opened my own. Then name it algorithm for getting yourself to Tclassified. So in the morning. So I said the algorithm are what? Step-by-step procedure of achieving an end. So let me give you an algorithm of Augustine Emeka Ikene coming to Tclassified every morning to teach you, so that from there you build out your own algorithm. So number one in the algorithm is step-by-step, isn't it? It must have a starting point and have an ending point, isn't it? So number one, you're going to write one dot. You now write wake up in the morning. That's the first step. Number two, kneel down and pray. Number three, go into the kitchen and boil hot water. Number four, take my bath and dress up. Number five, take small tea without bread. Number six, apply my perfume and other things that I needed and walk out of my house. Number three, go and on the generator. Number four, walk to my gate, get out of the gate and lock the door. Number five, walk down to Tclassify, open the door and get everything set. Number six, schedule the class. Number three, hook up to Zoom. Number four, teach. Now you see the algorithm. Do you understand what algorithm is now? It's very simple, you understand? So the way I explain this algorithm, if you're using Python, you should be able to code it out. If you're using C, you should be able to code it out because it's just the same thing. It's in English, it's very close to English. That's why we call it pseudocode, you understand? Then it's now left for a specialist in that very language to now transpose this thing from that algorithm into code. Is that clear? Which we are going to be learning. And we've done one yesterday. We did string reversal yesterday. Is that clear? And we did it with a very simple algorithm that is complicated. Today we're going to try out those same string reversal with basic language structure. So see when I see you, remember everything you want is in Christ Jesus. The easiest way to success is by being a born again. Thank you, Lord.